Hi, welcome to Prac 8. In this Prac, we're going to be looking at the effect heat has on the vitamin C content of various foods. So we've got some background here on vitamin C. It's an antioxidant. A number of fresh fruits and vegetables contain significant levels of vitamin C, particularly citrus fruits, and also green and red peppers are very high in vitamin C. So we know from the theory that vitamin C is deactivated whenever we use high heat. So in this example here, it's saying that up to 50% could actually be lost. And if you boil a vegetable in water, some of that vitamin C will leach out into the water. And once you drain that water, you could lose up to 75% of the vitamin C content of that original food. Now, this table here applies to naturally occurring vitamin C. In our experiment, we'll be using some naturally occurring vitamin C and also some artificial vitamin C in the form of absorbic acid. Okay, this experiment involves a titration using potassium iodate and will follow the reactions shown below. Now, the chemical reactions are complete when we see what's called an endpoint or color change. In our control, we're using vitamin C in the form of absorbic acid. We start off with a colorless solution, and once it just starts to change color to a bluish tinge, that's the endpoint. If it starts to go black, you've gone too far. The endpoint in the fruit and vegetable sample is a little bit more difficult to see because we're dealing with colored samples. In the orange juice sample, for example, the endpoint when it starts to go this greenish tinge. If it starts to go dark green, again, we've gone too far. Okay, here's the setup of the experiment. You've got our burette containing potassium iodate, and we've got our sample. So we'll be testing either the control sample, pure vitamin C, or one of the fruit juices or one of the vegetable juices. Right, so we're going to have a quick look at this video. It shows the titration process for determining vitamin C in a sample. So here's the YouTube video showing vitamin C titration using iodate. So in the video, they're going to show how you would actually set up a control, a known control with vitamin C. So ours would be similar. We'd also need to set up a control, and then we'd then go about testing the vitamin C content of the fruit juices and vegetable juices.
In this titration, we're going to titrate vitamin C against potassium iodate in the presence of excess potassium iodide. In fact, what happens during the titration is that the potassium iodate oxidizes the iodide ions to iodine, which are then reduced by the vitamin C back to iodide. And once all the vitamin C has been used up, then you see the presence of the iodine and the blue-black colour with the starch indicator that's included. So let's get on with that. First thing we've got to do is to measure out 25 centimetres cubed of vitamin C into this conical flask. Do that, we use the pipette filler. So there we go. Now I always prefer to use my finger control, so at that point I take the pipette filler off and use my finger to adjust to the line. I find I got more control that way. And you may see. So there, 25 mils.
Okay, so what we've got here is the vitamin C control. So all samples are then compared to this vitamin C control. So if we look at our Prac, here's our vitamin C control. So we need to set up that control similar to what's happening in that video. And then we need to set up the various samples. So we've got the vegetable juices and also some fruit juices as well.
during the titration, what we need is 5 mils of this 0.1 molar potassium iodide, so I just crudely measure that out using this, the graduations on this pipette here. So that's 2, that's 4, and that's 1, that's 5. We need 4 mils of the 2 molar hydrochloric acid, that's 1.5. That's 2.5, that's 4. And finally, 3 mils, 3 centimetres cubed of the starch indicator, 1.5, 3. So let's begin our titration. We're on 0.30 centimetres cubed. Just realised my hand's in the way. So you can see that as the iodate runs into the mixture, you get that characteristic blue-black iodine colour, but on swirling that should disappear as it's reduced back to iodide by the vitamin C that's present. As soon as all the vitamin C is used up, the blue-black colour of the iodine will persist, and that's when we stop.
Okay, so he slowly adds the solution until he gets to the end point. So the end point should be about here somewhere.
Almost, look. Remember, a permanent colour is one that lasts for at least 30 seconds. That one's still just disappearing. And how about that? That's at 27.
All right, so that's very similar to the endpoint we're expecting for our experiment. Okay, so we can't do the real titration, but instead what I'd like you guys to do is please have a go at this virtual titration. So just follow this link here. And as you're doing your virtual titration, the information I'd like you to record is the color of the solution before we start the titration, the color of the solution once we reach the end point, so the final color, and how much of the, in this case, they're using sodium hydroxide, so we need to know the amount in millimeters that's actually used to reach that particular endpoint. Okay, so here's the virtual titration I'd like you guys to have a go at. So in this one here, they're looking at an unknown solution. So this one is an unknown solution of acid, and they've got an unknown solution of an alkaline, sodium hydroxide. So by doing the titration, they can then estimate the amount of acid in the unknown solution. In our experiment, we've got our unknown amount of vitamin C in the fruit juices and vegetable juices, and we've got a known amount in the burette. Okay, you need to read quickly through the instructions here. Okay, pretty straightforward. So what we need to do is firstly add the indicator. So just pick up the eyedropper, add a couple of drops, we'll put that back. And then step 2, we need to then start the titration process by opening up the stopper and allowing some of the sodium hydroxide to come in. So this is going drop by drop. So they're saying each drop actually equals 1 mil. And you've got to wait until you've actually got the final color change. Okay, looks like I've gone too far, so what I'll need to do is reset. Start it again. So 4 drops was too much, so it must be just three drops. Okay, that must be the end point. I've just gone past it. So in that run, it looks like the end point was 17 mils. Yeah, so I've gone too far. So once you've had a go at that virtual titration, remember to enter in your results. And then for our experiment, I've got some results from last year that we can use. Right, so here's our results for table 1. There's our control. The vegetables that we're using, red pepper and green pepper. And then we've got orange juice. So that's some fresh orange juice. So we just squeeze up some oranges, and there's some commercial orange juice. Now, what these results are showing us is that the control, even after heating, is not actually being reduced. The vitamin C content is not being reduced. The reason being is that the control was absorbic acid, so that's a synthetic vitamin C, and the synthetic vitamin C is not being affected significantly by the heating process. Whereas the natural vitamin C, which we find in the red pepper, the green pepper, and the fresh juice, you can see there's been significant reduction. So red pepper here started with 15, now we've got 10. So we've lost about a third of the vitamin C, about 30%. The green pepper, about 12. So more than half. After 30 minutes, we've lost the vitamin C. So about 50%, maybe more than 50%. For the fresh juice, it's gone from about 4 down to 1. So we're down to 25%. So we've lost about 75% of the vitamin C. Now the commercial juice, I think this one was a UHT commercial juice. There hasn't been a significant reduction. So it appears that this commercial juice, they've just simply added some artificial vitamin C, some absorbic acid, similar to this control. So there is not a significant drop in the amount of vitamin C. All right, so we've also got some results. Sorry, so table 1 is just showing how many mils of iodate we used. And then in table 2, you use that information to calculate the actual amount of vitamin C present in the sample. So after you've done the calculations, you end up with this result here. But again, it's showing no significant reduction in the artificial vitamin C, not a significant reduction in the commercial juice. Again, it's probably artificial vitamin C, but significant reduction in the vegetable juice and also the fruit juice. All right, so you should be able to write a brief discussion using last year's results, and then you can talk about the questions. Did you lose vitamin C? Yes, in the natural fruits and vegetables you did, but in the artificial ones, the control and also the commercial UHT orange juice, there was no significant loss because it's a synthetic vitamin C. And then which vegetable showed the greatest loss? Well, just looking at it, it seems to be the fresh orange juice, but you'll need to do some calculations. At home, what can you do? Well, at home, what you need to take care of is, the amount of heat and also whether you're cooking the vegetable in boiling water. So if we go back over here, so if I'm cooking the vegetable in boiling water, the vitamin C will leach out into the boiling water, and you'll lose some of that vitamin C as you drain away that water. Okay, so I think we've got enough information for you guys to write up this particular practical report. Thank you.